Okay, so hey there everyone. Today we are going to discuss this problem number 1287, that is element appearing more than 25% in the sorted array. And this is also today's POTD for 11th of December. And for the first time, I am seeing the longest streak of easy question in the problem of day that Leetcode is giving. So this is really shocking to me, but it is what it is. So let's start with the question. So the question is, given an integer array sorted in non-decreasing order, there is exactly one integer in the array that occurs more than 25% of the time, and you have to return that integer. It's very simple, that we are given with a sorted arrays, and that sorted array is sorted in non-decreasing order. It means simply increasing order. And now once we are given with this array, what we have to find is, they have also told us that there will be only one integer will be there which is occurring more than 25% of the time. And what we have to do is, we have to find this one integer and we have to return its value. So this is the simple question. Now here you can see that they have written sorted in bold format, so definitely they are giving us indication that since this is sorted, you can use something like binary search on it, or you can think in the way of binary search. Now there are many ways to solve this problem. First of all, I'm going to tell you two solutions. First solution will be a simple and naive solution, and after that we will try to look at some more optimized solution using binary search. So let's start with the logic first, and the logic will be very simple since the problem is also simple. But there is one thing that we have to look before jumping into the code, is that this 25% thing, that a number is occurring more than 25%, we have to look after this first. First of all, if we have to find a number which is occurring greater than 25%, the easiest way will be to calculate this 25% of whatever it is in a form of an integer number. And once we have that integer number, we will just check the frequency of all the elements, and if the frequency of any element is greater than or equal to this x, it means that it will be greater than 25% also. So we will be converting this percentage into some integer number, and from there it will be really easy for us to make a logic. So let's try to do this. So first of all, let me take the example as it is. So 1 2 2 6 6, 4 times 6, then 7, and then 10. So first of all, what is the length of this input array? So it is 3 plus 3 6 plus 3 9. Cool. So the length of this array currently is 9, and now the length of the array can be odd, that is n modulo 2 can be not equal to 0, or it can be even. It means that this n modulo 2 will be equal to 0, right? So these two possibilities are there, and in the first example I am taking the first possibility, that is the length of this array is even. And I will be also going to explain you one more example where I will be taking the length of input array as even. So first of all, let's have a look at this. When the length is 9, what will be the 25% of this 9? So in total there are 9 integers present in this array. So first of all, to convert this percentage into an integer number, let me find the 25% of 9. So when you will try to find the 25% of 9, you will get answer as 2.25. Now this 2.25 is not a perfect integer, but if we have any number which is occurring greater than 2.25, it will be called as repetition more than 25%. But we can't take this number 2.25, right? So what we can do over here is, we can take a seal of this number, whatever number that we are getting. After converting this 25 percentage into an integer, if we are getting some float value, or let's say some double value, we will be taking seal of it. So if you take seal of this value, we will get 3. What do you mean by seal? First of all, whenever I say seal value, it means that if any number is present in such a way like 2.1, 2.5 or let's say 2.9. Ceil means you have to take the next greatest integer that you can take. So for 2.9, what is the next greater integer that I can take? So that is 3. For 2.5, again if I ask what is the next greatest integer that I can take, so it will again is 3. And for 2.1, again if I ask you what will be the next greater integer immediate that I can take, you will again answer me as 3. So this is called as taking ceil of a number, right? So I hope you are clear what do I mean by a ceil function. So whenever we will get the value in decimal notation, we will definitely going to take ceil of it, and whatever it is, if any number is occurring greater than or equal to 3 times, like here I am considering this example. So if any number is occurring greater than or equal to 3 times in this array, then I will say that that number is occurring more than 25%, correct? So what I have to now just do is to make a map and to now calculate the frequency of each and every element. And after that, I will be traversing in the map and I will check if there is an integer whose frequency is greater than or equal to 3. If yes, then it will become my answer. So that was the simple logic, and now let me extend this logic for an even number also. So let me take one example to discuss the even length case. So let us consider example as 1, 3, 2 and 2. So here you can see that the length of this array is 4, which is even. Now if we try to apply the same logic that we have applied earlier, so what you will do, you will convert this 25 percentage again into an integer number, so it will become easy for me. So 25 percentage of 4, so this will be equal to 1. So now what you will say is this number is an exact number, this is not a decimal number, right? And what we are given in the question is that there is exactly one integer in the array that occurs more than 25%. Now you have to pay attention over here, is they have mentioned that the number is occurring more than 25, not more than or equal to 25%, right? They are strictly mentioning that it should be greater than 25%, which is strictly. It should not be equal to 25% also. Exactly, strictly greater than 25. So I can't take this one, because if I take this number as 1, and if I try to find a frequency of element that is repeating only once in the array, and if I return that as an answer, it will become wrong, because it is occurring exactly 25%, and what I want is I want the frequency to be greater than 25%. So the next immediate greater integer that I can take after this number 1 is 2, right? So I have to take this number as 2, and I have to check in my array that if such element exists whose frequency is greater than 2 or not. I will not be checking the frequency of element as 1, because if I try to do this for 1, I will get exact 25%, and I don't want that. I want strictly greater than 25. So if I am getting a perfect integer answer that is for an even number, in that case what I will do is I will increment that integer by 1 to make a next greater immediate integer, and I will be checking this integer. If any number is occurring more than or equal to this number, then I will definitely say that the occurrence is greater than 25%. So I hope everyone is clear with the logic. Now let's go and have a look at the code. This is my code. First of all, I have stored the length of my array in my variable n by using arr.size, and then I have made one variable, that is frequency, for 25%. So what will be the frequency of number that I have to look for in order to have that integer to be occurred in my array greater than 25%? So for that I have made this variable, and in this variable what I am doing is I am storing n by 4. Basically what I was doing was converting that 25% into an integer number. So 25 upon 100 into x was what I was doing. So if you just simplify that expression, that is 25 upon 100 into x, you will get that expression as x by 4. So that's why I have directly written that simplified expression, that is x, whatever number I am taking, divided by 4. And now why I have explicitly converted this integer into double over here. Now this should be a question, because the ceil function only works on my float values, or I can say or double values. On that only we can apply ceil. That is a really obvious thing. So we should be first converting any of the number explicitly into double, so that my resultant value is in form of decimal whenever it is possible, and then I will be taking ceil of it. Cool. And now, as I have explained you earlier during the logic, that if in case the length is even, then if I am getting an exact answer for frequency for 25%, I will be taking the next greater integer in order so that that particular number occurs more than 25%. So that's why I have done plus is equal to 1 whatever value I am getting for frequency for 25% if that length is even. After that, simply I am making one map and I am setting my answer as -1. But as they have told us that each and every time they will be setting the test case in such a way that you will be getting some answer. So this -1 will always be updated with whatever answer is there. Cool. And after that, what I am doing, I am traversing through my array and I am adding the frequency of each and every number, how many times each and every number is occurring in the array to my map. And once I am done with that, I will be traversing through be trying to find a particular number whose frequency is greater than or equal to the value that I have stored in this variable, that is frequency for 25%. If I am able to find such a number in my map, then that's it. That number will be my answer. So I'll be storing that number into my answer variable, and I will just break from over here, since we have been told that there is only one integer. And once we find that one integer, then there is no point in moving ahead. So I will break over here and I will simply return that answer. So this was the naive approach. Now I will be showing you that how we can do the same thing in a little optimized way using the binary search. Now here is the another method to solve this question using binary search. So first of all, up till this part, you can see that the code is exactly same as I have told you in the naive approach, that we are going to calculate the frequency for 25%, and if it is even, then we will increment it by 1. And I have also explained you why we were doing this kind of thing. Now from here onwards, from the 11th line, the code is changing. So what we are going to do over here is I am making some pointer variable, remain this pointer variable till it is lesser than my array size. After that, I have declared one more variable answer that will be storing that particular number which is occurring more than 25%. At the end of the day, I will be returning that particular answer, and in between I will be applying some logic. So what I am doing over here is I have applied one while loop, and inside the while loop the condition is until my pointer is lesser than err.size, I have to do certain things. So first of all, whatever is the current element, I will try to apply lower bound on that current element, since we have already been given that this array is sorted. So there is no need to sort this array, we can directly apply the lower bound and upper bound function. Now what does this lower bound function do? So basically, if the array is sorted, then if we try to find any element, that is whichever element that I am mentioning over here, what lower bound will do, it will try to search for that element in this particular array. If lower bound finds the exact same number that I am looking for, then it will return me that particular index. And if it is not able to find that element, it will return me just the next greater element. So this is what the lower bound is doing. Now what upper bound is doing, let us try to understand. Whatever element I write over here, since I am writing this current element, it will try to find the next greater element than current element. Let's say if the current element is 2, so it will try to find in this array what is the just next greater element immediate to this. So it is 6 over here. So it will store the index of 6 and not the 2. Okay, so upper bound will always look for the element which is just greater than the element that we are looking for. So I hope you are clear with the usage of this lower bound and upper bound. So whatever element I am currently at, I will try to find the lower bound of it. It means I will try to find the start index of this. Once I have done that, I will try to find the end index of that particular thing. Let's say I am on element 6, like here you can see this element 6. I will try to find the starting index of this. So hence I am applying lower bound with my current element as 6. So what it will do, it will keep on searching in this array and it will return, since the 6 element as it is present in the array, so it will return me the index of the first occurrence of that number, that is of 6 over here in this case. So it will return me this index as my start index. And when I will apply the upper bound with current element is 6, it will return me this index of 7. Since this all number are 6, and what upper bound do, as I have told you, it will always give me the index of the just next greater number than the number that we are looking for. So currently we are looking for 6, and the just greater number as compared to 6 which is present in our array is 7. So it will give me this index as my end index, correct? So now I have start index as 0, 1, 2, 3. So I have start index as 3, and what is my end index? So 3, 4, 5, 6, 7. So my end index is 7 and start index is 3 right now. So what I will do, I will be trying to find how many times this 6 has occurred. To find the frequency, what I will simply do, end index minus start index, that is 7 minus 3, which will be equal to 4. And as you can see over here, that 6 is repeating 4 times, which is equal to end index minus start index. So if this is greater than or equal to my frequency for 25%, then yes, we have found our number. So just store that number and break from there. But if we are not able to find it, then we have to move ahead. Now here we won't be moving ahead linearly by incrementing our pointer by 1, but you can see over here is that we are moving our pointer by the value of end index. Whatever is my end index right now, here my end index will be here on 7, so I will directly move my pointer to 7. I won't be incrementing my pointer to from index number 3 to 4, then 4 to 5, because I already know that in index 3, 4, 5 and 6 the number are same, that is 6, and I have already done binary search for 6. So there is no logic in incrementing it to index number 4, 5 and 6. So I will be directly incrementing my pointer to the end of the index. So in this way we can save upon this number of iterations, and hence this is a little bit optimized. So this is how we are doing over here, and finally we'll be returning whatever our answer is. So let us try to submit this also. So yes, it is accepted. So that was it. That was the simple solution. I hope that both the methods are clear to you. That is the first naive approach as well as little bit optimized approach using binary search. And if you have understood this, then please leave us with a like and subscribe for more such content. Thank you.